Hello, my Year 7 scientists. We're going to do some revision about acids and alkalis now. Pay attention, make notes, pause the video and go back a bit if you need to. Let's make a start. We're going to start off with acids. We're going to try and start with acids. Maybe I can click it like this. There we go, acids. So acids are sharp tasting. They have a pH less than 7 and they're sometimes corrosive. Next one, the opposite of an acid is an alkali. Alkalis have a soapy or bitter taste. They feel slimy. They've got a pH higher than 7 on the pH scale. A nice example of an alkali is sodium hydroxide. Next are indicators. Indicators show us what the pH of an acid or alkali are. We use universal indicator most of all, but we can also use blue or red litmus paper. There are times when acids and alkalis cancel each other out. This is called neutralization. Neutralization is important for keeping things safe. When we made our salt in class using an acid and an alkali, we neutralize each other so that when we evaporated off the water, we wouldn't have any acid or alkali left with our salt. There's 4 chemical reactions that you need to know. Those 4 have 3 of them are making the same products, which is quite useful for you. I'll go through the 4, but not in the order they're on the screen. An acid and an alkali make salt and water. This is your basic number 1 example. The second one is acid plus hydroxide makes salt and water as well. If you had hydrochloric acid and sodium hydroxide, then you would make sodium chloride and water as our products. The third one is an acid with an oxide, makes salt and water. It's the third time the ending has been the same. For example, if we had hydrochloric acid and we had magnesium oxide, we'd make magnesium chloride and water. The last one is when you've got an acid and a metal, which makes salt and hydrogen. For example, if we had nitric acid and we had magnesium metal, it would make magnesium nitrate and hydrogen gas. And you could test for the hydrogen gas because it would burn with a squeaky pop. Next, we've got 4 symbols. The first one means toxic, a skull and crossbones. The second one is corrosive. That means that the substance will eat through surfaces or even your skin. The third one means there is a hazard. And the fourth one is it's dangerous to health. Next, we have the pH scale. These are the colours that we use on universal indicator. They go through the spectrum from red through orange, yellow, green, blue, indigo and violet. In the middle is neutral things. pH 7 is neutral. It's not acid, it's not alkali. Numbers less than 7, as I said before, are acid. So something like urine or saliva or black coffee are weak acids. They're close to neutral, but they're not neutral. Something which is much stronger, like lemon juice or hydrochloric acid, has a much lower pH. It's closer to 1. And so it's a strong acid. At the other end of the scale, we've got things like seawater and baking soda, which are much weaker in the alkali scale than things like liquid drain cleaner, which is a really strong alkali. It has a purple colour and a pH of 14. The scale goes beyond the 1 to 14 that we learn in school, but I'm not going to do that in Year 7 yet. Next, we've got the types of salt that we make. Hydrochloric acid always makes a chloride. So whichever of those 4 reactions we had above, if we had hydrochloric acid with magnesium, would end up with magnesium chloride and hydrogen. Sulfuric acid makes sulfates. So magnesium plus sulfuric acid would make magnesium sulfate and hydrogen. Nitric acid makes nitrates. So if you had magnesium with nitric acid, you'd make magnesium nitrate and hydrogen. When it comes to concentration, the number of particles is the important part. If you have a dilute acid, it means there aren't many particles of acid inside water. A concentrated acid means you've got lots of particles of acid in a little bit of, or the same amount of water. So my diagrams there show that there's a few particles in dilute and lots of particles in a concentrated solution. I hope that you've enjoyed and learned a little bit from my acids and alkalis revision video.